speaking about what's the difference between traditional and on-premise and modern cloud differences. That's what we did. Just carrying on. As DevOps engineers, we need to know what is what in a architectural perspective, because we work on real-time applications. There are multiple architectural perspectives when we build applications. Some of these are what you see on the screen. So you have your entire, which is multi-tier architecture, which is a pretty common architectural style when we are working with modern applications. You have web queue worker kind of an architecture. What is that? Is whenever we are working with a banking kind of an application or a retail kind of an application, like Walmart, Tesco, these are retail chains. So they have a huge number of requests coming in day in, day out. So if I just make a note that. So whenever there is requests which are coming in for say Walmart, a huge number of requests coming in. What is the request consisting of? He needs the customer wants the retail products to be delivered out to his doorstep. So he would have just bought a few kilos of potatoes, tomatoes, and some vegetables, milk. This is what they do. They just do online shopping for these things, and these things are delivered to the doorstep. So usually they keep ordering it daily, day in, day out. They get millions of requests in a given point of time, depending upon where they are located, in US or Central US or wherever. So they can't, the server can't take these requests directly. If you keep on pumping these many requests to the server, there are high chances that your server cannot process, and most of the requests would be in queuing state. If the request is in queuing state, then the user would just see the loader in the page, and his order is never accepted. So what would they do? Instead of directly triggering the request to the server, they will put queuing servers. That is what is your web queue worker. These servers just take in these requests and queue them. So the customer is happily ordering something and moving on. This is essentially the same thing with your Flipkart or your Amazon. Amazon server doesn't take the request. It is the queuing server which takes the request. And you get a success or a failure, saying your order has been successfully placed or you have failed placing an order, but your order is in the queue yet. It is not processed by the server yet. It is only processed by your queue servers. Queuing servers are very efficient in handling high traffics, and you would be having in a good architecture wherein you have multiple you have millions of requests which are pouring in each day in, day out. Then you would be having in your architecture queuing servers. That's about queuing servers. So that's what is your web queue worker. What is microservice? We have another kind of architecture which is called as microservices architecture. I'll just say arc. So what is microservices architecture? Whenever you have multiple services, like what is the first thing you do going to Amazon? What is the first thing you do? You land on Amazon. What is the first thing you do? Do you browse the page or do you search for something? You came to Amazon with the idea in your head that you will be buying something, right? You don't just come here to browse the home page. Very less we do that. We usually try buying something on Amazon. So I would be having an idea that I will buy a mobile today. I'll just search for mobile. In the same way, what is it that is very frequently used when I'm coming to Amazon? What is the function? I can go ahead and this search is a function. Then I can go ahead and look at some mobile. I can go ahead and add to the cart. I have added to the cart. The add item to cart is a function. That's another function. I'll go ahead and proceed to buy. It will ask me to log in. That's a different thing. So I'll go ahead and proceed to buy. That's another function. So I keep on going from one function to other function. Whenever I'm going ahead and placing some order or doing something on my website. The thing which you need to understand here, search among all this, which is the thing that you think which is most frequently used by all the users. A person may or may not add items to the cart. A person may or may not go to the proceed items to buy. But he will definitely search for something. He would keep on searching for something. Your refrigerators or your refurbished mobile phones, you keep saying it. People keep on searching. What is the one functionality which is efficient, very commonly used? It is a search. If I have a server, that's my client. If I have a server, the server has all these features. The search, the add, and checkout. The traffic is too high. I'm getting too many requests. It's too high. And most of the requests are dealing with the search guy. So this is the guy who is, most of the times, that is the functionality which is being asked for. That is, people are searching for it. I want to scale my architecture. How do I scale it? I'll create another. In that server, I'll deploy the application. If I deploy the application, I'll get search, add, checkout. There is a problem with this architecture. My problem was search being very aggressively used. And what did I do? I deployed the entire application so that I can handle the request. But the request would have been handled if I independently scaled only search. I need not scale the entire application for that. That is what is microservices architecture. What is microservices architecture? You build each service as a microservice. Search is an independent service. Search is an independent service. Add item to cart is an independent service. Buy is an independent service. Tomorrow, I have a scenario like this, that search is excessively used. What will I branch out? I will just branch out search. I'll only branch out search and I'll create multiple deployments of search. Why? That is the only functionality which is being used repeatedly. So I'll independently branch out search and I'll have the search functionality deployed many times. I'll have this. That is what is microservice. What is a microservice? You can independently scale. You need not scale the entire application. If one operation of yours is very frequently used, why do you want to scale up every operation? You can just scale that thing out. So how can I plug this out and deploy it like this? I need to use microservices. So just do a simple read on what microservices are and stuff. We don't want to go deeper into it. I'm just giving you clues and how you can work with different kinds of architecture and what is the idea behind these architectures. So you have different kinds of architectures. So microservices is one of the architecture. You have CQRS, you have event-driven architecture, you have big data, big compute, all of this. So we don't want to go deeper into all the architectures, but just understand you have multiple deployment strategies which companies take, depending upon the scenario in which your application is being developed. Depending upon that, your architectures differ. If your architectures differ, your deployment differs. If your deployment differs, your CI/CD pipeline differs. That's where I'm coming. You and me as DevOps engineer are responsible for the CI/CD pipeline. We build the pipeline. So if our architecture is different, our pipeline would be built in a different way. So just that is where I'm coming from. So just have a tap on different architectures, what architectures are, and what are the different ways in which we can work with different kinds of architectures. Just have a simple read about it. You and me are not architects, that's for sure. Even as developers, it is better that we have some understanding of the architecture in which we are working on. So that is where I'm coming. So have some good understanding on different kinds of architectures which are out there. Moving forward. So what does the cloud do? The cloud goes ahead and shifts the application design principles. What are those? It essentially is designed for self-healing. That is your 99.99% availability, which we were speaking about in the last session. Essentially, what I'm saying as a Microsoft team is your application will be 99.99% available. That is essentially 100% available. Why is it 100% available? Why is it designed for self-healing? Because I have replicated in multiple regions. So that's what I have done with my self-healing kind of concept. In the self-healing, there are other things which will come in. One of the things is your replication. You replicate your code in multiple regions. You deploy your application in multiple regions so that even if one region is down, I can go ahead and get the other region up and running. That's what is self-healing. So it understands that one region is completely down and the requests are waiting in the pipeline, and it will allow you to redirect your request, your future request to the other region. So that is what is self-healing. It makes most of the things redundant. Again, replication, redundancy, all of that come in the same pattern. So you replicate and you make most of the things redundant. You minimize coordination. So essentially, these replicated instances are not coordinating with each other directly. They are having an intermediate like a load balancer, or in Azure terms, you call it traffic manager. Just do some little bit of reading around traffic manager and what traffic manager does for you and how is it different from load balancer. Have a good read about it. That's what this guy is speaking about, the minimizing coordination. He's speaking about the traffic manager kind of a scenario. And you design it to scale out. There are two different kinds of methodologies in which I can scale my application. I can scale in and I can scale out. You essentially design your application to scale out whenever you're building it in a Azure kind of a deployment methodology. And you partition around limits. Essentially, this is to do with your databases. You create partitions, and each partition is taking care of a set of data. That is what is partitioning all about. That is another thing what you do whenever you're deploying your application in your Azure environment. You have the flexibility of partitioning it. That is another new term, or that is another on-prem term which you take to the Azure world, the partitioning of your database. And you design for operations. So that's your ops. When you say DevOps, you design for DevOps. So that's what is Azure all about. It brings everything into one umbrella. And you can now work end-to-end when you are actually going ahead and working with an application which is on DevOps. You're working end-to-end right from requirement gathering to deploying the application in live. So all of that is taken care in one go. So you design for operations. So the end goal is my operations. You design for operations when you're working with Azure. And you use managed services. What are managed services? We'll come to that in next slide. We'll just have a quick look at it. We'll not go deeper into it. We are not an Azure session. We are Azure DevOps session. So we need not concentrate on services that much. So services, what are the different services which are offered by Azure and stuff? We'll just have a simple look at it and then move on with our discussion. So we use best data store for the job. So it is nothing like whenever I want to store data, I have to go with MS SQL database. That's not the case. I have multiple kinds of databases: blobs, document DBs, the Cosmos DB, your file DB, you name it. What are the different DBs which are available? You just have multiple DBs. Let me just go to the official website. If you look at products, databases, what are the kind of DBs which I have? The Cosmos DB, the SQL, Data Factory, PostgreSQL, you say PostgreSQL, MySQL, your Edge, warehouses, Redis. Look at how many options I have when I speak about databases. That's what is this slide saying. Use the best data store for the job. It's nothing like I have to go with structured DB. You have a plethora of options, and for the job which you are working on, or the application you are working on, depending upon the application you're working on, use the best database for that job. You have multiple choices out there. And what is useful in what case? Yeah, you need to do some exploration there. That's why I keep going to the official website. Just click on anything. They will clearly give you what is being done in this storage and how you can use this storage and what are the uses of using this storage. There are clear indications and clear pointers to go ahead and work with any kind of storages. That's another thing. And it is designed for evolution. That is, it will evolve eventually. We'll just ignore it. Built for the needs of business. Yeah. So essentially, any application is built for the needs of the business. Business asks for something. Depending upon what the business is asking for, I'll go ahead and build it to actually go ahead and build it for the needs of the business. That is what I do in any application. That is what even in Azure we are doing. So what are the main cloud quality practices which are present in Azure as well? You have scalability. So I can scale in and I can scale out. So I can deal with my architecture in a different way. Depending upon the demand which I have, I can go ahead and scale my application and meet the demand of my requirement. So that is what is the elastic nature of your Azure cloud. So you actually can go ahead and scale it out and go ahead and meet your customer demands. Once the demand is low, you can go ahead and shrink it back to your original shape. So essentially, that's one major concern. Whenever I am an architect, the first thing which I will be thinking about is these two factors: scalability and availability. These are very important to me as an architect. And Azure, once you go to Azure, architect's 50% of responsibility is gone, because scalability and availability is already there. Availability 99.99%, which is promised by Microsoft. The architect can forget about availability feature. Scalability, all I need to do is just a click of a button. That's how simple it is for me to scale my application. I can go ahead and scale my application the way I want. Then resiliency. So essentially, your application has to be resilient. It has to respond, and it has to give some answer. It can't crash. So that's what is resiliency. That is another architectural practice which is given to me by my Azure portal. Another thing, your management of your application and the security of your application. These are the main practices which I as a engineer or I as an architect have in our minds, and these are the things which have to be taken care of whenever we are working with any application, and Azure takes good care of these constraints. These are very important quality practices, and all of these things are taken care very easily when you are working with Azure. So what to use for running your applications in Azure? A very big question. You have multiple options. You can use IaaS, PaaS, or LaaS. LaaS is Logic as a Service. It is also called as Software as a Service. So don't get confused. Both are same. We saw that in our previous sessions. What is the difference between IaaS, PaaS, and SaaS? We saw all that. So it is called SaaS as well as it is called Logic as a Service. LaaS. Both are fine. Both are saying the same thing. So don't get confused there. You have multiple options when you are building your application and when you are deploying your application in Azure. Then you are comparing the options, your amount of responsibility and control, where they run. So essentially, as you move on from IaaS to PaaS, the responsibility what you are taking is reducing. So from IaaS, if I start here, more responsibility. If I use a PaaS environment, somewhat less responsibility. LaaS or SaaS, completely no responsibility. All of it is taken care by your vendor, by your Microsoft cloud vendor. So that is what is are the options what I have when I'm working with any of my deployment strategy. What is the other thing? Whenever I want to deploy my applications, the main advantages of using Azure, you have high availability as we have spoken. We have good security, scalability, and your cost effectiveness. All of this is what we already spoke about. I don't want to stress about. Just moving on. Whenever I want to deploy something in Azure, I have multiple options. What are the multiple options? I can go ahead and deploy it in a VM, the virtual machine. So I can go ahead and deploy my application in the VM. That's your IaaS offering. So whenever I want to deploy my application in the VM, what I'm saying, I want more control. I don't want you to manage my system. That is essentially I as a banking application or a retail application. I don't want Microsoft to manage my code or Microsoft to manage my application. I'm more skeptic about it. So what will I do? I'll go for a VM kind of a deployment. I will buy a VM on Azure or I'll allocate a VM on Azure and I'll go ahead and deploy my code inside the VM and I'll manage the VM. What is it that you are doing when you are managing VM? You as a company are responsible for, you as a team are responsible for updating your VM with any security patches and having your VM in a healthy state without it shutting down and stuff like that. And having your security checks done on your VM because your VM is it is exposing some of the ports so that the external internet can connect to your VM. So having the security checks done on your VM, the antivirus installation and the firewall installation on the VM, that's your responsibility. All of these things are the things which I need to take care of when I go with a VM kind of a deployment. It's pretty painful and if possible, push your client to use a PaaS kind of a environment than a VM kind of an environment. It would make your life easy. It would not make his life easy, it would make your life easy. What are the other things which we have? We have a container service. What's a container service? And what are containers? These are lightweight things than your virtual machines. What is that? It is essentially whenever you're working with containers, they don't have the heavy lifting of what a virtual machine has. That's your container versus VMs. When we speak about VMs, we definitely will speak about containers. What are containers? If we just look at the diagram, what is there inside the VM and what is not there in the container? There is something which is very important. It has app. It also has app. It has some bin libs. It also has bin libs. It doesn't have something. It doesn't have a OS. What is it using? The container. The container is using the host OS. what is my VM using? On top of host OS, it has its own OS. Each VM has its own OS. VM doesn't run on the hosting OS. It will have its own OS. If you have any exposure to virtual machines, you should know it. We can have multiple virtual machines on our machine installed, and each virtual machine will have its own operating system. They just took the heavy lifting thing out. It's a totally different discussion. What are containers and how they will improve my deployment strategy, and how are they more efficient than VMs? It's a completely different discussion. It's more towards microservices. We spoke about microservices, right? It's more towards microservices and dealing with microservices. So that is what is what your VM versus container is. So essentially, we're just looking at the image, just to understand. Container is a lightweight thing than my VM. VM is pretty heavy, and they got something very smart, which is a container. And the most famous container technology out there is your Docker. If you just look at my desktop, so I use Docker. So it's a very famous way of deploying your applications inside your production environment. They are pretty lightweight, they are very performant, and there are huge benefits of using Docker kind of a technology. And when you work with Docker, you again get some other thing orchestrated, which is called as Kubernetes. Once you start learning about Docker, you will end up learning about Kubernetes as well. So essentially, these are a few things which you need not know as a DevOps engineer. I'm just giving these things as extra information, so that you actually don't be blank when you're actually hearing these terms. You at least should have a one-line answer to it, that you at least understand to some extent, because these are concepts within themselves. I can take another 10 days to just explain to you how Docker works and what are the advantages of Docker and what's Kubernetes and stuff like that. So these are independent topics in themselves. So we're not exploring that. We are in the DevOps world. So this is just for your information, so that you're not blank when you hear these terms like Docker and stuff. That's your container service. It will help me deploy containers. What are containers? We just saw that. The container versus VMs. So it will help me deploy my VMs or my containers. It will help me deploy my application in a container kind of an architecture rather than a virtual machine kind of an architecture. We have multiple things. The container service will help me deploy my application in multiple containers. The container instances will help me deploy my application in one instance. If I just want one instance, I'll go with container instances. If I have multiple instances, I'll go with container service, web apps. That's what you use to deploy your application. And web apps for containers, you are essentially using web apps. So there are two kinds of services which are available on Azure. If you already used Azure, you should be familiar with it. If you did not, that's fine. You have cloud service. So you have Azure App Services and your cloud service. A pretty decently famous topic. You can see the number of hits which I got. Pretty much decently discussed online of what's good and what's bad, and what is it that I want to use in what scenario. So you can just have a look at what a web job is, what a web app is, what a cloud service is, and what a web app is. There are a huge number of differences between these two guys. I'll just name it in a few lines, but just understand there are two deployment methodologies which I can deploy when I'm deploying my web application. What is my application essentially? Whatever is the application which you're seeing, Facebook, Amazon, your Microsoft website which you're seeing, all of that. What are those applications? They're all web apps, web applications. That's what is a web app. It will help me deploy a web app. I can deploy it as a cloud service as well. Why will I use it as a cloud service? Why will I use it as a web app? There are multiple reasons why I do that. I'll just speak about it. And you can also deploy it as a batch. What's a batch? So whenever you have batch processing, this is more towards big data. So when you are having big data kind of an environment and you want to go ahead and build your, not build, process your data in an efficient manner. That is where you will be doing your batch processing. So you go ahead and process your application or your data in batches. That is parallel processing. If at all you are familiar with parallel processing, that's when you will use something like a batch service. There is a service which is given by Azure, which is called as a batch service, which will help build your application in or process your application in batches. That is what it will do. It will go ahead and process your application in batches. That's your batch service. This is another thing which is available to you in the cloud. Then you have service fabric. This is what is being used in Azure to host Azure itself. So whenever you are having service fabric, as you see the logo, it is having 5 nodes. So what is service fabric? It is more to do with your container kind of an environment. Whenever I am deploying my application in a container, like I'll go ahead and deploy my application inside, deploy in containers. Whenever I deploy my app in the containers, I'll not have one container. I'll have a batch of containers. What are those batch of containers? That is what you will be using in ASP.NET. One of the solutions for that is service fabric. That's your batch of containers. You have 5 nodes. Each node will have a container, and all the nodes can speak to each other. Can I only have 5? Can't I have more than that? You can have 10, you can have 20. But it will be a cost. You have to pay for that. It all depends upon how rich your client is. But you would at least have 5. It will be either 1 or once you scale it up. It will not scale it up to 2. It will scale it up to 5. So when you are scaling up your application in using a service fabric kind of environment, it will scale it up to 5. So essentially, you can control that as well. You can scale it up to 2 and you can control that as well. But it is recommended to have the 5-node cluster. That's what you call as clusters in your deployment methodology. And we're looking at this kind of deployment as well. If you just go to your, that's your Azure Service Fabric. One of the places where you can deploy. You see the 5 nodes, the 5 nodes. When you're building your pipeline, when you go ahead and say new pipeline, it will say, where do you want to deploy the code? That is what is the question. This is how do you want to package the code? That is what is your build. Release is where do you want to deploy the code? Do you want to deploy it as an app service? Do you want to deploy it as a container? Do you want to deploy it as a service fabric? That's what is, depending upon my architecture, I would go for a service fabric kind of a deployment. That is what we are looking at here. So that's why it is important. It is up to me. I will decide. I, along with architect, it is your architect who decides. But essentially, I also have, as a DevOps engineer, I should have an idea about, even though my architect says we will go with service fabric kind of a deployment, you should at least have a couple of lines of idea that you should just essentially have a couple of lines in your head regarding what service fabric is and why do we deploy it in a service fabric kind of architecture. That is where we are just looking at what I'm saying. Whenever you are having a microservice kind of architecture, you would be deploying it in a container, like your Docker container. And whenever you deploy it in the Docker container, you don't deploy it alone. You will deploy it as a cluster. That's what is service fabric. It will allow me to deploy my app as a cluster, as a clustered application. That's what a service fabric is all about. Moving on, cloud services. That's one major um, discussion point when I'm looking for my deployment strategy, or if I want the PaaS offering. I don't want to use the IaaS offering of it. I want to use the PaaS offering of my virtual machine, of my Azure deployment strategy. So in the PaaS, the first thing what you will be looking at, platform as a service. In the PaaS, what is the first thing what you will be looking at is cloud services. I can deploy my web app inside the cloud service. Why will I use a cloud service versus why will I use an app service or a web app? That's the next thing, the web app. These two guys are pretty confusing because they both give me the same features. But there is a small difference between these two guys. So if I just go one of the differences site, it's a big tag of what to use when. Let me just highlight some of the difference, not all. The web app, the web apps, and the cloud services. These are the two famous PaaS offerings. Whenever I'm looking at the platform as a service, I will definitely come across these two terminologies because that's what you will see in the Azure portal. In Azure portal, you can use one of these two. What are these two? So what will they do? Essentially, both are supporting all the languages. So that's fine for me. Where is it that it will differ is even the DevOps stuff is the same. I just want to see the virtual machine login, the remote desktop login. Not required. Azure does not does OS patching, and it does it. Where is the remote login stuff? This guy totally missed it. So essentially, whenever this is fast, that's for sure. Your web app, this is much faster. And Microsoft says, use this, don't use this. Cloud services, what is the advantage? I am using PaaS, but I want to have control over the VM or where is it exactly deployed. I don't want it to be black box because Microsoft can host my application in any other application in a server wherein the other 10 applications are staged. So I don't want that. I as a customer am saying no. I want complete control on where my application is deployed. Give me complete control over that. That's when you use cloud services. Cloud services will allow you to go ahead and remote log in. Wherever your website is deployed, you can remote log into that machine and see what is deployed and add a few add-ons. Why do you want control over it? What? I don't trust Microsoft as a company. There are customers, like banking customers and stuff. They say we don't trust you, that you would maintain our application safely. Please give us control. We trust you to some extent wherein you are a branded company and you can help me host my application. But I can't completely give my application to you. Give me control. So there are customers who say that. So they want control over their application. That's where you would go ahead and say Microsoft's cloud services. That's where you will go ahead and use cloud services. Wherein you want remote desktop access and web app, that's a modern way of deploying your application. It's very fast. When they actually started in 2010 or 2009, when Microsoft actually started, they started with cloud services. Whenever you want to deploy your application, you deploy it in a cloud service. They did not have web app. Web app is the latest offering which they have given. Back then, I used to use web app. Just 5 years before this, I used to use not web apps. I used to use cloud services. That's what I used to deploy my app in. Now I don't use it because of the performance aspect as well as many benefits which I get using web app. Just do a simple read on why will I deploy it to web app or why will I deploy it to cloud. If you look at your pipeline, Azure App Service, that's web app. So don't get confused. Azure App Service is web app. You see that logo, that's the same logo here, the dots and stuff. So it's a web app. So whenever I'm deploying something, I deploy it using a web app. If at all I want cloud service, did they completely remove it? If at all I want to deploy it as a cloud service, that is what I do. So in my CI/CD pipeline, I as a DevOps engineer should understand why will I use web app as a deployment, or why will I use a cloud service as my deployment strategy. Why will I use a cloud service as my deployment strategy? It all is your and my decision as software engineers and DevOps engineers. It is our decision, and we should make smart decisions for the team for which we are working on. It all depends upon multiple scenarios. So just do a simple read on what web app is and what cloud services, so that you can get a good understanding, because these two are quite confusing. Your mobile app, pretty straightforward. I need not explain. Why will you use a mobile app service? Whenever you have a mobile app application which you want to deploy, you would go ahead and use the mobile app service. Pretty straightforward. Can I deploy my mobile app as a web app? Yes, you can deploy it. And people do that. So nothing like you have to deploy your mobile application as a mobile app, in a mobile app service only. You can go ahead and deploy your application inside a cloud service or inside a web app. It's not something which is not possible. But mobile app service has many things which it gives out of box when you have a mobile app service. Your mobile app application has a requirement wherein it has to send notification. We have notifications, right? Your mobile applications keep pumping notifications. You have Zomato installed, you have Book My Show installed, or you have any other application installed. They keep on pushing notifications on your notification code. When you scroll down and see, you can see multiple. That's what they want to do. They want to grab your attention. And it is very easy for me to work with a mobile app and go ahead and structure it to actually pump notifications to my clients from a mobile app. It is not so straightforward to do it from a web app. So it all depends upon my scenario. And mobile app has its own advantages, like I just said. It will allow you to go ahead and pump notifications whenever you have a requirement of that sort from your mobile app service. That is another service which you have. What is the other service? You have function apps. You have functions. What are functions? These are more towards just logic. If I have a logic which I want to execute, and I just have that logic to be executed, that's what is logic as a service or function as a service. You have a logic which you want to execute on a particular server. Normally speaking, whenever I have this kind of a scenario, I will wrap up this logic inside a console application. If you are familiar with console applications, inside the ASP.NET console application, I'll wrap it up in a console application, then I'll create an EXE. What will the console application give me? DLL or EXE? What will it give? It will give me an EXE. I will wrap it up in a console application, then I'll deploy it in the cloud and I'll execute it. The EXE. Instead of doing all that thing, if you have a requirement, then you have a particular logic which needs to be executed, what you will do, you will go ahead and wrap up that logic as a function. That's what you call as a function. You will go ahead and wrap up the logic as a function. Then you will deploy that function in the cloud. And once you have deployed this function, you can access your multiple applications or multiple services. That is what you can use directly whenever you are working with Azure. That is, you can directly invoke functions from your Azure portal. You have logic app. Essentially, again, your function, your logic, all of that are coming under the SaaS offerings, software as a service, or logic as a service. That is where they are having problem.